Hello, my friend, and welcome to the Sleepy Scholar. Tonight, we are not going to look at the world as it usually appears: solid, obvious, easy to trust. Tonight, we are going to look at the cracks, because underneath the ordinary surface of things, there are little places where logic folds in on itself, where the rules that seem so certain during the day quietly stop making sense. Paradoxes are not tricks. They are not riddles meant to embarrass you. They are more like doorways, small, strange openings, where the universe lets you see that it is stranger and softer and less rigid than it appears. You may have had a long day. Perhaps your mind has been running since the moment you woke up, sorting and worrying and replaying. That's all right. You don't need sharp thinking tonight. You don't need to solve anything. In fact, that's rather the point of a paradox. It isn't meant to be solved so much as rested inside of. Tonight is not for figuring things out. It's for wondering gently and then drifting. So let's not rush. There is nowhere else you need to be tonight, and nothing you need to finish. We'll wander gently through 7 strange and beautiful paradoxes, puzzles about time, identity, distance, and the dark sky above you. And we'll let each one loosen something in your mind rather than tighten it. Think of tonight less like a lecture and more like a slow walk through an old, quiet garden after dark, where every so often you come across a strange little statue or a fountain that seems to run backward, or a hedge shaped like something you can't quite place. You don't have to understand the garden. You only have to keep walking slowly, letting each strange shape pass by, trusting that you don't need to memorize the path to enjoy having wandered it. And if these gentle journeys ever help you rest, you're welcome to like or subscribe, only if it feels natural. It simply helps other sleepy souls find their way here too, into this same quiet corner. Now, let's get comfortable. Let your body begin to soften, wherever it happens to be right now. You don't have to move. Just notice the places where you're being held: the mattress, the pillow, the blanket, and let yourself sink a little further into them. Let your shoulders drop, even slightly, away from your ears. Let your jaw unclench. Let your tongue fall loose from the roof of your mouth. Let your hands go heavy, your fingers uncurl. With every breath out, let it be a little slower than the one before. You don't have to control it. You don't have to do this well. There's no version of this that's wrong. Let your legs go heavy too, sinking into the mattress. Let your feet fall open, loose, at whatever angle feels most natural. If you're holding tension anywhere else, your forehead, your chest, the space between your eyebrows, just notice it gently and let it soften by even a small %. Not all at once, just a little. That's enough. You don't need to remember anything I say tonight. You don't need to follow every idea or stay awake for the ending or make sense of it all. Nothing here is a test, and nothing will be asked of you afterward. If your mind wanders, that's not a failure. That's just what tired minds do, and it's allowed. In fact, your mind is really just a prediction machine, quietly trying to guess what happens next all day long. That's tiring work. Tonight, you can let it stop guessing. You can let this slow, steady voice do the wondering for a while, so your own mind doesn't have to. So let your body settle and your mind drift as we begin. Here is a strange question to start with. If you replace every part of a ship, plank by plank, until not a single original piece remains, is it still the same ship? This is called the Ship of Theseus, and it comes from a story the ancient writer Plutarch told almost 2,000 years ago about the mythical hero Theseus and the ship he supposedly sailed. The Athenians, the story goes, kept that ship in their harbor as a monument, and over the years, whenever a plank rotted, they replaced it with new wood. Eventually, plank by plank, beam by beam, the entire vessel had been swapped out. Nothing of the original remained, and yet everyone still called it the same ship. It sailed the same waters. It bore the same name. There's a quieter, softer way to feel this puzzle, and it's this: you are also a kind of ship. Almost every cell in your body will be replaced over the coming years. Your skin renews itself in a matter of weeks. Your bones rebuild themselves over roughly a decade. The atoms in you tonight are not the same atoms that were in you as a child, and yet you are still you. Whatever you means, it isn't the material. It's something more like a pattern, a shape, a story that keeps being retold in new material. So when you feel like you've changed, grown, healed, become someone slightly different than you were last year, that's not a loss of yourself. That's simply the ship, quietly being rebuilt, plank by gentle plank, while still carrying the same name safely across the water. There is a quieter cousin to this puzzle, one the philosopher Heraclitus offered even earlier, more than 2,500 years ago. He said that you cannot step into the same river twice. At first, this sounds almost too simple to be strange, but sit with it for a moment. The water touching your foot right now has already moved on, downstream, replaced by new water flowing in behind it. The riverbank shifts too, grain by grain, year by year. The river you name, the Mississippi, the Thames, the little creek behind a childhood home, was never one fixed thing. It was always a pattern of flowing, given a single, comforting name so that the mind could hold on to it. Heraclitus went further and said that not even the person stepping into the river is the same person twice. The you of this evening is not identical to the you of this morning. A little more tired, a little more changed by the hours in between, made of slightly rearranged thoughts and slightly different blood chemistry. And yet, nobody finds this alarming, because the name stays the same and the story stays continuous. Rivers and people were never meant to be frozen. They were only ever meant to flow gently while still being called by one steady name. There is something else worth resting on for a moment, still tucked inside this same old ship. Suppose, the philosophers later added, that someone collected every original plank as it was removed, every old, rotting piece of wood, and secretly rebuilt a second ship from them, off in some hidden dock. Now there are two ships. One has all the new wood and the old name, still sailing. The other has all the original material, but has been sitting unused and unnamed. Which one is the real Ship of Theseus? Most people's instinct pulls in two directions at once. The one that kept sailing feels real because it's the one that continued. The one people watched and touched and used. But the one built from original wood feels real because it's made of the actual physical stuff that was there at the very beginning. There isn't a clean answer, and that's all right. It means identity was never really about the material to begin with. It was always about which thread you decide to follow, the substance or the story. You carry this same soft duality in your own life, more than you might realize. The photographs of you as a small child, the material of that small body, are almost entirely gone now, replaced many times over. But the story that connects that child to you tonight, lying here, that thread never broke. That's the version of you that's real, not the atoms, the thread. There's a small, homely version of this same puzzle that people still repeat today, sometimes called the story of the old family axe, or, in some tellings, an old broom. A worker says proudly that he has used the very same axe for 30 years. He has, of course, replaced the handle 4 times and the head twice. Nothing original remains. And yet, he isn't lying exactly when he calls it the same axe. He's pointing at something real, a continuity of purpose, of use, of place in his life, even while admitting, in the same breath, that not one original atom of wood or metal survives. Identity, it turns out, was rarely about the material to begin with, not for ships, not for rivers, not for old family tools, and most gently of all, not for you either. There's a version of this same puzzle hiding in cities, too. A city like Rome or London has existed under the same name for well over 1,000 years. And yet, almost nothing physical remains from its earliest form. Buildings have been rebuilt, the streets rerouted, the walls torn down and raised again elsewhere, and every single person who once lived there has long since died and been replaced, generation after generation, by entirely new inhabitants who never knew the old ones. And still, we speak of Rome as one continuous place, carrying one long memory, one identity, across 2,000 years of complete material turnover. A city, like a ship, like a river, like you, was never really its bricks. It was always its story, quietly retold by whoever happens to be living inside it at the time. Even a single word carries this same soft paradox. The English word, nice, once meant foolish or ignorant. Its meaning has drifted almost completely over the last 700 years, passing through meanings like fussy and precise, and finally arriving at pleasant. Not one thread of its original sense survives intact, and yet dictionaries still confidently print it as one continuous word, one entry, one identity, stretched across centuries of quiet, gradual change. Words, ships, rivers, cities, and people. It seems the things we're most certain remain the same are almost always the things that have changed the most. The philosopher John Locke, writing in the late 1600s, offered a gentler answer specifically for people, suggesting that what makes you you over time isn't your body at all, but the quiet thread of memory that connects each moment to the last. In his view, you are the same person you were 10 years ago, not because any atom survived, but because you can remember, however faintly, being that person, a soft chain of recollection linking oneself to the next, like lantern light passed hand to hand down a long, dim hallway. But even memory has its own gentle gaps. You don't actually remember most of your own life. Entire years dissolve quietly, leaving only a handful of scenes, a few smells, a couple of remembered conversations, standing in for thousands of forgotten ordinary days. And yet, no one doubts that all those forgotten days still belong to them, still shaped them, still count as part of one continuous life, even without a single clear memory attached. Perhaps identity was never meant to be provable, moment to moment. Perhaps it was always meant to be trusted, the way you trust, without evidence, that you'll still be you tomorrow morning, simply because you always have been before. There's a strange modern echo of the Ship of Theseus, tucked inside something as ordinary as a computer file. When you copy a photo from one device to another, the new copy isn't made of any of the same original material. No original magnetic charge, no original electrons. It's an entirely new physical arrangement of information, built fresh, somewhere else. And yet, everyone agrees it's still the same photo, pixel for pixel, memory for memory. If you then delete the original, most people still feel the photo survived, simply by having moved, plank by digital plank, into new material. Identity, once again, quietly reveals itself to be about the pattern, never the substance, true for ships built of oak, and just as true for photographs built of light and code. You can find this same soft puzzle growing quietly in a forest, too. An old-growth forest can stand in one place for thousands of years, and yet almost none of the actual trees are that old. Most trees eventually fall, decay, and feed the soil for whatever grows up next in their place. A coral reef behaves the same way. The reef you might picture, vast, colorful, ancient, is really a living structure built by countless tiny coral polyps, most of them alive for only a few years each. Generation quietly building on generation, depositing limestone on top of the skeletons of the ones before them. The Great Barrier Reef, in its current form, has been growing this way for roughly 20,000 years. And yet, no coral alive today was there for more than a small handful of those years. The reef, like the ship, like the forest, like you, was never really its individual living parts. It was always the shape those parts kept gently agreeing to take, one short lifetime handed to the next. Your own body keeps a quiet, precise version of this same schedule, if you'd like a specific one to rest your attention on for a moment. The soft lining of your stomach renews itself every few days, constantly rebuilding itself against its own digestive acid. Your red blood cells live for about 4 months before being replaced. The outer layer of your skin sheds and regrows roughly every few weeks, meaning the surface you touch tonight didn't exist a month ago. Your skeleton, slower and steadier than the rest, fully rebuilds itself over roughly 10 years, cell by patient cell. Almost none of this happens with your notice or permission. Your body has simply been quietly performing its own small ship of Theseus, plank by plank, for every single day you've been alive, and it has never once lost track of who it was rebuilding. There's one gentler exception worth knowing, tucked quietly inside your own skull. Most of the neurons in your brain's cerebral cortex, the part responsible for thought, memory, and awareness, are believed to last your entire lifetime, formed mostly before birth and rarely replaced afterward, while your skin and blood and bones are constantly being rebuilt around you. A good portion of the very cells doing your thinking tonight are, in a sense, the oldest continuous part of you. There is quiet, patient originals, present in some form since very close to the beginning, carrying you forward the entire time everything else was being replaced around them. In a strange, comforting way, some small part of you really has been there for all of it, unbroken, the whole way through. But that is only one small part of the story of identity. There is a second paradox waiting, this one about time itself, and about a person stepping backward into it. Imagine, just for a moment, that time travel into the past were possible. And imagine a person traveled back before their own grandfather ever met their grandmother, and through some unfortunate accident prevented that meeting from ever happening. If the meeting never happens, the parent is never born. If the parent is never born, neither is the traveler. But if the traveler was never born, they couldn't have gone back in time to prevent the meeting in the first place. The chain breaks its own foundation. This is called the grandfather paradox, and it has kept physicists gently circling it for over a century. One of the quieter resolutions physicists have offered is called the Novikov self-consistency principle. It suggests that if time travel to the past were ever truly possible, the universe simply wouldn't allow contradictions to occur. Something would always intervene, a delay, a coincidence, a small twist of fate, so that history remains whole and consistent. Not because anyone is forcing it to be so, but because a universe that erased its own foundations couldn't exist to be observed at all. In this gentle version of the idea, time doesn't fight you. It simply agrees only to the paths that don't unmake themselves. There is a strange comfort hidden in that principle if you let it settle. Whatever has already happened to you, every choice, every accident, every quiet turn your life has taken, has become part of a consistent, unbroken thread. It doesn't need defending or fixing anymore. It already fits together, simply because it happened, and here you are. There's a related idea worth wandering through, called the bootstrap paradox. Imagine someone travels back in time and hands a famous composer the sheet music for a song that composer will later become known for, a song that, in this version of events, the composer never actually wrote. Where did the song come from then? It was given to the composer, who wrote it down and made it famous. But the traveler only had the song because the composer had, at some future point, written it. The same song they were just handed. It exists, fully formed, without ever being created by anyone. It simply loops. Physicists sometimes call this kind of closed loop a causal loop. And general relativity, Einstein's theory of gravity, technically allows for shapes of spacetime called closed time-like curves, where such loops could, in principle, exist, especially in extreme conditions like a rotating universe, an idea explored mathematically by the logician Kurt Gödel in 1949. No one has ever built one, or needs to. It's enough for tonight to imagine a song that came from nowhere and everywhere at once. A small circle of time, holding itself gently together, needing no beginning at all. Some physicists prefer an entirely different way of softening the grandfather paradox, one that comes from an idea called the many worlds interpretation. In this gentle picture, whenever a moment of true branching occurs, a choice made, an accident avoided, a meeting prevented, reality doesn't have to choose only one outcome and erase the rest. Instead, the universe quietly splits, like a single trunk sending out two branches, each one becoming its own separate world, both fully real, neither one canceling the other. In this version, if a traveler went back and prevented their grandparents from meeting, they wouldn't unmake themselves. They would simply step sideways into a different branch, one where their own timeline continues untouched, safely on a nearby branch of the same great tree. You don't have to believe this is literally true to borrow its comfort. There is something soothing in imagining that no choice, however difficult, ever truly erases what came before it. That somewhere, in some sense, every version of the path still exists, still branching gently outward, still growing, and that the version of tonight where you finally let yourself rest is simply one more branch, quietly unfolding exactly as it should. There's an older, quieter cousin of the grandfather paradox that comes not from physics, but from ancient stories, called the predestination paradox, or sometimes the self-fulfilling prophecy. In the old Greek story of Oedipus, a king hears a prophecy that his newborn son will one day kill him. To prevent it, he sends the infant away to die. But the child survives, is raised elsewhere, and grows up never knowing his true parentage. And it is precisely because he was sent away that, years later, as a stranger, he unknowingly crosses paths with and kills the man who turns out to be his father, exactly as foretold. Every effort made to avoid the prophecy became one of the very steps that fulfilled it. There's something almost eerie and almost comforting about this shape of story, depending on how you hold it. It suggests that trying too hard to outrun a particular fear can sometimes be the very thing that walks you toward it, while also suggesting, more gently, that whatever unfolds as one connected, complete story, without any wasted or contradictory pieces. You don't need to worry tonight about which of your own small actions might loop back around later. You can simply let the story continue, one gentle page at a time, trusting that it doesn't need your supervision to make sense. There's a real experiment, strange enough to sound almost like time travel, called the delayed choice quantum eraser, first proposed in the 1980s and carried out in various forms since. Without needing every technical detail, the gentle shape of it is this: tiny particles of light seem to behave differently depending on whether they are being watched in a particular way. And in some versions of the experiment, the choice of whether to watch is made after the particle has already, in some sense, completed its journey. It's tempting to describe this as a future choice reaching backward to affect the past. And some popular explanations do describe it that way. Physicists who study it closely are more careful and generally conclude that no actual information or influence ever truly travels backward in time. The strangeness lives instead in how quantum particles hold multiple possibilities at once, until the full picture is gently pieced together. Still, the experiment lingers in the mind precisely because it brushes so close to the same soft territory as the grandfather paradox. The sense that cause and effect, so rigid and orderly in ordinary daylight life, might be woven a little more loosely at the smallest scales of reality. You don't need to resolve any of this tonight. You can simply let the strangeness sit there, a small, glimmering, unresolved thread, the kind physicists themselves are still gently pulling on. The physicist Stephen Hawking once offered a gentler, more playful piece of evidence for a related idea he called the chronology protection conjecture. The notion that the laws of physics might quietly forbid time travel into the past altogether. In 2009, he hosted a small party specifically for time travelers, complete with balloons and champagne, but sent out the invitations only after the party had already taken place, reasoning that only a genuine visitor from the future could possibly receive an invitation to an event already in the past. No one came. He took the empty room as gentle, good-humored evidence in favor of his idea. Not proof, just a small nod toward the possibility that some paradoxes might not need clever resolutions at all, because the universe may have simply, quietly closed that particular door before it was ever opened. There's something almost comforting in a party with no guests, a door that was never meant to be walked through, a paradox handled not by clever argument, but by simply, gently, not existing in the first place. If reaching backward into the past turns out to be forbidden, reaching forward into the future has always been quietly possible, in its own patient way. In 1940, a group in Oswego, New York, buried what they called the crypt of civilization, a sealed chamber packed with recordings, artifacts, and everyday objects meant to describe life at the time, not to be opened until the year 8113, a date chosen simply because it marked as much time forward from 1940 as the earliest known human civilizations stretched backward from it. No living person who helped seal that crypt will ever know whether anyone actually opens it, or what they'll think when they do. It sits there right now, quietly sealed, patiently waiting. A message thrown gently forward across more than 6,000 years, trusting a future it will never get to witness. There's a gentler, more personal echo of the same idea sitting in millions of ordinary homes in the form of the humble time capsule, a shoebox of letters and photographs, a jar buried in a backyard, a note tucked into the frame of a house, meant to be opened by someone years later, sometimes even by the very same person who buried it. The strange comfort in writing to a future self or a future stranger is that it asks for nothing back. It doesn't require an answer or even survival. Only the small act of trusting that time will keep moving forward the way it always has, faithfully carrying the message along without needing anyone to push it. Whatever you're carrying tonight that feels unfinished can be treated a little like that kind of letter, sealed gently, set down, and trusted to whatever quieter, more rested version of you meets it tomorrow. There is something else worth resting on for a moment, a puzzle less about the past and more about a very quiet, very old silence above you. In the summer of 1950, the physicist Enrico Fermi was having lunch with colleagues, casually discussing recent reports of unidentified flying objects, when he apparently posed a simple, almost offhand question. Given how vast and old the universe is, where is everybody? This has since become known as the Fermi Paradox, and it's a puzzle less about equations and more about a strange, uncomfortable silence. Consider the numbers gently, without trying to hold them tightly. The Milky Way alone contains somewhere between 100 and 400 billion stars. Many of those stars have planets. Some fraction of those planets sit in the right zone for liquid water. The universe has existed for roughly 13.8 billion years. Plenty of time, in theory, for intelligent life to have arisen many times over, in many places, and for at least some of it to have developed the technology to become noticeable, to send out ships or signals or light. And yet, when we quietly listen to the sky, we hear almost nothing back. Scientists have proposed something called the Great Filter, the idea that somewhere along the long road from simple chemistry to a spacefaring civilization, there exists at least one extraordinarily difficult step, one so improbable that almost nothing makes it past. The unsettling question is whether humanity has already passed that filter, back when life first sparked from non-life, or whether the filter still lies ahead of us, somewhere in our future. You don't need to carry that question tonight as a worry. You can simply let it sit there, unanswered, the way the sky itself does, vast, quiet, patient, without any need to be resolved before morning. There's a way of turning that same vast uncertainty into something more like arithmetic, developed by the astronomer Frank Drake in 1961, called the Drake equation. It doesn't give a final answer. It simply lays out, gently, the string of unknown fractions that would need to be multiplied together to guess how many communicating civilizations might exist in our galaxy right now. How many stars form each year? What fraction have planets? What fraction of those planets could support life? What fraction of that life becomes intelligent? What fraction of intelligent life develops the ability to signal across space? And quietly, the most uncertain number of all, how long such a civilization typically survives before falling silent, whether from disaster or simply from changing so much it becomes unrecognizable to itself. Every single one of those numbers, except the first, remains a soft guess. Some optimistic versions of the equation suggest the galaxy should be humming with thousands of civilizations. Some pessimistic versions suggest we might be entirely, achingly alone. The truth is, nobody knows, and won't for a very long time, possibly ever. There's something almost restful in an equation that admits, so plainly, that some of the biggest questions simply don't have their numbers filled in yet, and that it's all right to leave a few blanks in your own equation too, at least for tonight. There is a gentler side to this same puzzle, one that isn't about danger, but about scale, and about a golden record. In 1977, humanity attached a golden phonograph record to each of the 2 Voyager spacecraft before launching them outward, past the edge of the solar system. The records contained sounds and images meant to represent life on Earth, whale songs, greetings in 55 languages, a mother's kiss, the sound of wind, of laughter, of a heartbeat. Both spacecraft are now farther from Earth than any human-made object has ever traveled, drifting in the near-total emptiness between stars, carrying that small golden echo of home outward into a silence that may never answer. It will take the Voyager spacecraft roughly 40,000 years to come anywhere near another star system. And even then, they won't stop. They'll simply continue on forever, unless something intercepts them. In a very real sense, a small piece of your own species is already out there right now, drifting gently through the dark. At this very moment, while you rest here beneath the same sky it left from. Some thinkers have offered a quieter, more unsettling answer to Fermi's original question, one sometimes called the dark forest hypothesis. It suggests that the universe might be full of life after all, but that every civilization has learned to stay silent on purpose. The way a creature in a dark forest holds still and says nothing, because announcing your location to the unknown might not be wise. In this picture, the silence isn't emptiness. It's caution, repeated by everyone, everywhere, all at once, out of a shared and reasonable wariness. It's only one guess among many, unproven and perhaps unprovable. But it does gently explain why a sky so large could still sound so hushed, not because nothing is out there, but because everything out there has simply, quietly, learned to listen rather than call out. There's also a gentler measuring stick for imagining how far a civilization might one day travel along this road, called the Kardashev scale, proposed in 1964. It imagines 3 broad levels: a civilization that has learned to use all the energy available on its home planet, one that has learned to harness the entire energy output of its home star, perhaps by surrounding it with structures called Dyson spheres, and one that could someday draw on the energy of an entire galaxy. By this scale, humanity hasn't even fully reached the first level yet. We are, in the kindest sense, still very young, a species just beginning to light its own small fire, in a universe old enough to have watched countless fires rise and fall already. There's a gentler, quieter possibility too, called the rare Earth hypothesis, which suggests that simple life might actually be fairly common across the universe, appearing wherever the chemistry is right. But that complex, intelligent life might require an almost absurdly long and delicate chain of coincidences to arise at all. A stable star that doesn't flare too violently, a large moon that steadies a planet's tilt, a nearby giant planet that quietly sweeps away dangerous debris, plate tectonics that slowly recycle carbon over billions of years, and simple chemistry that happens to stumble against long odds into something that can think about itself. If this gentler hypothesis is closer to true, the universe might be softly alive in countless quiet places, with complex minds like yours remaining a rare, almost accidental gift, rather than a common outcome. Either way, crowded or nearly empty, the not knowing is, in its own way, a kind of privacy. Whatever is happening tonight on your own small, quiet planet, spinning gently through a mostly silent galaxy, is happening without anyone else's eyes on it, as far as anyone can currently tell. There is something oddly restful in that kind of cosmic privacy, the sense that this moment, this rest, this breath, belongs entirely and only to you. There's a quiet philosophical idea worth resting beside this one, called the anthropic principle. It points out, gently, that any living, thinking being who ever wonders about the universe's conditions will always find themselves in a universe capable of producing living, thinking beings, simply because they couldn't be anywhere else to do the wondering. It sounds almost circular, and in a sense it is, but it carries a soft truth. Out of all the possible universes, with all their possible physical laws, only the rare ones gentle enough to allow atoms, stars, and eventually minds to form, would ever contain someone lying quietly in the dark, wondering how unlikely their own existence really is. You are, in this sense, standing on genuinely rare ground, in a universe fine-tuned enough, by whatever process, to have made a moment like this one possible at all. In August of 1977, an astronomer named Jerry Amen, working on a radio telescope project called Big Ear at Ohio State University, was reviewing a fresh stack of printouts when he noticed a burst of radio signal far stronger and stranger than the ordinary background noise. A signal that matched, almost eerily well, the theoretical profile scientists expected an artificial, intelligent transmission might have. Startled, he circled the sequence of numbers and letters on the printout in red pen and wrote a single word beside it. Wow. It has been called the wow signal ever since. Astronomers pointed instruments back at that same patch of sky many times over the following decades, and it was never detected again. Not once, not by anyone, not in the same form. To this day, no one knows for certain what caused it. Most likely, careful scientists will tell you it was something mundane, a passing comet, an overlooked satellite, an unusual reflection of Earth's own signals. But the file remains gently, officially unsolved. One small red-circled wow on an old sheet of paper, filed away in an archive, standing as one of the closest brushes humanity has ever had with the possibility of an answer to Fermi's old question. Somewhere quietly, a radio telescope is still listening tonight, patiently, the way it has for decades, waiting for that same brief, bright moment to happen again. More recently, some scientists have widened the search beyond listening for deliberate radio messages, looking instead for what are sometimes called technosignatures. Quiet, accidental fingerprints a civilization might leave behind without ever meaning to send a message at all. This could mean unusual chemical patterns in a distant planet's atmosphere, produced by industry or agriculture. It could mean an oddly shaped dimming of a star's light, hinting at some enormous structure built in orbit around it. In 2015, astronomers noticed a star, catalogued as KIC 8,462,852, and nicknamed Tabby's star, dimming in strange, irregular patterns unlike anything else observed, briefly sparking excited speculation about enormous artificial structures. Careful follow-up study eventually pointed toward a much quieter, more natural explanation, likely uneven clouds of dust. But for a little while, an ordinary star gave the whole world permission to wonder together, out loud. The astronomer Carl Sagan offered a gentle way to feel just how young humanity's entire presence really is, by compressing the whole 13.8 billion year history of the universe into a single calendar year. On this scale, the universe begins on the first moment of January 1st, and tonight, this very moment falls on December 31st. In this compressed year, our sun and earth don't even form until early September. The earliest simple life appears in the ocean around the middle of September. Dinosaurs don't arrive until the day after Christmas, and they vanish again the day after that. All of recorded human history, every pyramid, every empire, every war and poem, and quiet bedtime story ever told, fits into the final 14 seconds before midnight on December 31st. You are living right now in the last handful of seconds of a cosmic year that took the universe 12 full months to build up to. Every worry from today, every task left unfinished, exists inside a sliver of time so small that the calendar itself can barely hold it. And still, the universe built its entire enormous year just to arrive gently at this particular last second, holding you. But that is only one small part of the story of distance. There is a much older paradox about distance too, one that doesn't reach toward the stars, but toward something as small and near as your own footsteps. More than 2,000 years ago, a philosopher named Zeno of Elea proposed a puzzle that still quietly troubles people today. Imagine the fastest runner in the world, Achilles, racing a tortoise that has been given a small head start. Zeno argued that Achilles could never actually catch the tortoise, because by the time Achilles reaches the tortoise's starting point, the tortoise will have moved a little farther ahead. And by the time Achilles reaches that new point, the tortoise will have moved a little farther still. This repeats forever, an infinite number of times, and so Zeno concluded Achilles can approach the tortoise, but never truly overtake it. Of course, in the real world, fast things do overtake slow things constantly. The paradox isn't really about running. It's about what happens when you try to divide something continuous, like distance or time, into infinitely many pieces, and then try to add them all back up. It feels like infinity should mean forever, but it doesn't have to. Mathematicians eventually showed, using tools that would become calculus, that an infinite number of shrinking pieces can still add up to a small, finite, ordinary distance. Infinity, in this case, isn't a wall. It's just a very fine kind of thread, one so finely divided that it still measures only a few footsteps. There's a gentleness in that resolution if you let it settle over you. Sometimes a problem feels infinite, an infinite list of worries, an infinite stretch of night before sleep finally comes, simply because you're looking at it divided into too many small pieces. Zoom out just slightly, and the infinite pieces quietly resolve back into something small and finishable, the way footsteps always eventually cross a finish line, no matter how many times you imagine slicing the distance in half. Zeno offered another version of this same idea, sometimes called the dichotomy paradox, which is even quieter. To walk across a room, he said, you must first walk halfway there. But before that, you must walk a quarter of the way. And before that, an eighth. And before that, a 16th, and so on forever, back toward zero. There are infinitely many halfway points between you and any destination. And yet, somehow, people cross rooms constantly, without even noticing the infinite staircase folded quietly beneath every step. Zeno had a third version too, called the arrow paradox, and this one is stranger still. He argued that at any single, frozen instant in time, a flying arrow occupies exactly one position in space, meaning that, in that instant, it isn't moving at all. And since time itself is made of nothing but instants, one after another, the arrow is motionless in every single one of them. So how does it ever move? This paradox lingered, mostly unresolved in a fully satisfying way, until the development of calculus gave mathematicians a way to describe motion not as a series of frozen positions, but as a rate of change, a gentle, continuous flow, rather than a flipbook of still frames. Motion, it turns out, was never hiding in any single frozen moment. It only ever lived in the space between them. There's one more quiet cousin of Zeno's puzzles worth resting on, sometimes called Thomson's lamp, offered by the philosopher James F. Thomson in 1954. Imagine a lamp with a switch. You turn it on. After half a minute, you turn it off. After a quarter of a minute more, you turn it on again. After an eighth of a minute, off again. Each pause exactly half as long as the one before, so that infinitely many switches happen within a single minute. When that minute is finally up, is the lamp on or off? There's no way to answer, because the sequence never actually settles on a final switch. It simply approaches the 1 minute mark forever, without ever quite arriving at a last flick. This kind of puzzle is sometimes called a supertask, an infinite number of steps meant to be completed in a finite span of time. Nothing in the real, physical world seems to actually work this way. Switches have limits. Hands get tired. Atoms can't subdivide their motions forever. But as a thought experiment, it does something soft and useful. It shows that not every well-formed question has to have an answer waiting at the end of it. Some questions are built in a way that gently refuses to resolve, and the kindest thing you can do with them is set them down, unfinished, the way you might set down a book at the end of a long day, without needing to reach the final page before you sleep. There's a wonderfully strange puzzle from the mathematician David Hilbert from the early 20th century, sometimes called Hilbert's Hotel, that lingers gently in this same territory of infinity. Imagine a hotel with infinitely many rooms, every single one of them occupied. A new guest arrives, and the hotel appears completely full. And yet the manager simply asks every current guest to move from their room to the next room over. Room 1 to room 2, room 2 to room 3, and so on, forever. Since there is no final room to run out of, every guest still has a room, and room number 1 is now free for the new arrival. Somehow, a completely full hotel just made space for someone new, simply by everyone shifting over gently together, one small step at a time. Infinity, it turns out, doesn't behave the way ordinary quantities do. A full hotel and a hotel with room to spare can, impossibly, be exactly the same hotel. There's a soft metaphor tucked inside that, if you're willing to borrow it. Sometimes a life that feels completely full, with no space left for anything new, only needs everyone and everything already inside it to shift over by one small, gentle room, to quietly make space for whatever wants to arrive next. The mathematician Georg Cantor, working in the late 1800s, discovered something even stranger tucked inside this same idea, that not all infinities are the same size. It seems as though it should be impossible for one infinite collection to be larger than another. Infinite is infinite, after all. And yet Cantor showed, through a careful and rather beautiful argument, that the infinity of whole numbers 1, 2, 3, and onward forever is genuinely, provably smaller than the infinity of all the points along a simple number line. Both go on forever. One kind of forever is still larger than the other. This discovery unsettled mathematicians so deeply at the time that some refused to accept it for years. And Cantor himself faced harsh criticism from respected colleagues who found the idea almost offensive to reason. Today, it's simply an accepted, foundational part of mathematics, taught gently to students without controversy. It's a quiet reminder that even something as certain sounding as infinity once needed time and patience and a willingness to sit with discomfort before it could finally be understood and eventually rested in. There's a quieter riddle sitting beside all of Zeno's puzzles, sometimes called the arrow of time, though it comes from a different branch of physics, entirely thermodynamics. Almost every basic law of physics works exactly the same whether you run it forward or backward in time. A single collision between two billiard balls looks equally correct played forward or in reverse. And yet the larger world clearly, stubbornly moves in only one direction. Ice cubes melt into water. Water never spontaneously refreezes itself on a warm table. A dropped glass shatters. Shattered glass never leaps back together into a cup. The explanation lies in something called entropy, a gentle measure of disorder, which tends to increase over time simply because there are vastly more ways for things to be disordered than to be ordered. There are countless arrangements of shattered glass, and only one arrangement that forms an intact cup. So disorder is simply, overwhelmingly, statistically more likely, moment after moment. This quiet statistical drift is thought to be the true reason time seems to flow in only one direction at all. Why you remember yesterday and not tomorrow. Why mornings become evenings and not the reverse. You, too, are gently governed by this same soft arrow, drifting tonight from a slightly more ordered wakefulness toward a slightly more disordered, looser, more scattered state of mind, which happens to be exactly what sleep is. There's a quieter, more literary cousin of these infinity puzzles, sometimes called the Tristram Shandy Paradox, named for a long, rambling 18th century novel by Lawrence Sterne. In the story, the narrator, Tristram, attempts to write the complete account of his own life, but he finds that describing even a single day of it takes him a full year of writing, since he insists on capturing every small detail. At that rate, the philosopher Bertrand Russell later pointed out, Tristram falls behind his own life a little further with every passing year, and if he lived forever, he would never, ever catch up to the present moment. And yet, strangely, if he truly lived and wrote forever, every single day of his life would still, eventually, get written down, just very, very far in the future relative to when it happened. It's a gentle, almost comforting kind of impossible arithmetic, falling further behind every year while somehow still, someday, reaching every page. You don't need to fully write down or account for today either before you're allowed to rest. Whatever went unrecorded, unresolved, or unfinished about it can simply wait patiently, the way Tristram's story waits, for whatever slower, later version of you might eventually get around to it. It's worth resting for a moment, too, on why Zeno bothered inventing any of these puzzles in the first place. He wasn't simply trying to be clever. He was a student of the philosopher Parmenides, who taught that all of reality is really one single, unchanging, undivided whole, and that motion, change, and multiplicity are only illusions layered over that deeper stillness. Zeno's paradoxes were originally meant as a kind of gentle defense of his teacher's strange claim. If trying to divide motion or distance into separate moving parts leads to contradictions like Achilles never catching the tortoise, Zeno reasoned, then perhaps motion and division were never quite real to begin, with only a comfortable story layered over something more whole and still underneath. Modern physics didn't end up agreeing that motion is an illusion, but there's something quietly lovely in Zeno's original intention, if you let it settle. Underneath all the counting, dividing, and measuring the waking mind does all day, there really might be something more whole and undivided sitting patiently beneath it, unbothered by any of that counting. A kind of stillness that was there before the tortoise ever started walking, and that will still be there, undivided, once you finally close your eyes. There's something else worth resting on now, a puzzle about time again, but this time about how it doesn't move at the same speed for everyone. In the early 20th century, Albert Einstein showed something the human mind finds almost impossible to feel intuitively. That time does not pass at a fixed, universal rate. It passes differently depending on how fast you're moving and how strong the gravity around you is. This gives rise to what's called the twin paradox. Imagine a set of twins. One boards a spaceship and travels at extremely high speed to a distant star and back, while the other stays quietly on Earth. When the traveling twin returns, they will have aged less than the twin who stayed behind, not because of anything strange happening to their body, but because time itself passed more slowly for them the faster they moved. This isn't just a thought experiment tucked away in old physics textbooks. It's been measured gently and repeatedly in the real world. Tiny particles called muons, created when cosmic rays strike our atmosphere, decay so quickly that under ordinary assumptions, almost none of them should survive long enough to reach the ground. And yet detectors on the surface of the Earth catch them constantly because their high speed slows down their own internal clocks, letting them live, in effect, a little longer than they otherwise would. And the satellites that make GPS work in your phone have to have their onboard clocks corrected daily, specifically because they experience time slightly differently than clocks on the ground, due to both their speed and their distance from Earth's gravity. To picture the muons a little more closely, they're born roughly 10 miles up, high in the atmosphere, and they decay away almost immediately, with an average lifetime of only about 2/millionths of a second, traveling even near the speed of light. Ordinary arithmetic says they should only cover about 2/3 of a kilometer before decaying, nowhere near far enough to reach the ground. And yet enormous numbers of them are detected at sea level every single day in laboratories all over the world. Time dilation is the only reason. From our vantage point, their internal clocks are simply running slow enough to stretch that brief, fleeting couple of millionths of a second, just enough to let them finish the journey. A tiny, invisible particle, born and dying in less time than it takes to blink, quietly proves one of the strangest ideas in physics, over and over again, completely unnoticed, above your head, every day of your life. Even astronauts carry a very small version of this. Scott Kelly, who spent nearly a year aboard the International Space Station, returned to Earth having aged a tiny fraction of a second less than his identical twin brother, Mark Kelly, who remained on the ground. A real, measured difference, though far too small to notice in daily life. Somewhere quietly, right now, satellites above you are living in a very slightly different rhythm of time than you are, and your own life, moving at ordinary human speeds, is proceeding at very nearly, but not quite, the fastest possible rate that time can pass. There's a quieter, gentler version of this same stretching happening in your own phone right now. In fact, resting somewhere nearby. The satellites that make GPS work orbit roughly 12,000 miles up, moving fast enough and sitting far enough from Earth's gravity that their onboard clocks drift out of sync with clocks on the ground by about 38 microseconds every single day. A number so small it sounds meaningless, until you realize that without correcting for it constantly, GPS positions would drift by several miles within a single day, turning street directions, gently, quietly useless. Engineers simply built the correction into the system from the very beginning, so that satellites gently, invisibly account for the bending of time itself. Every day, just so a map on a screen can still point you home. There's a deeper, quieter layer beneath the twin paradox, called the relativity of simultaneity. It turns out that two events happening at the same time is not a fixed, universal fact. It depends on how fast you happen to be moving when you observe them. Two people moving at different speeds can genuinely, correctly disagree about which of two distant events happened first, and neither of them is wrong. There is no single master clock ticking somewhere in the sky, keeping the one true now for the whole universe. Every observer carries their own now, gently offset from everyone else's, and all of those nows are equally real. Near the edge of a black hole, this stretching becomes almost unimaginably extreme. To a distant observer, watching something fall toward the boundary called the event horizon, that object would appear to move slower and slower, its light stretching and dimming, seeming to freeze there almost forever, without ever quite crossing over. While from the falling object's own perspective, time would feel completely ordinary, and the crossing would happen quickly and unremarkably. Two honest descriptions of the same fall, disagreeing completely, both true. Time, it turns out, was never the strict, single-file line it feels like from inside an ordinary day. It was always this soft, bendable thing, different for every observer, gentle enough to stretch around whoever is watching. Gravity bends this same softness too, quietly, even here on Earth. Clocks placed at higher altitude, say, at the top of a mountain, genuinely tick very slightly faster than clocks left down at sea level, because they sit a little farther from the pull of the planet's mass. This has actually been measured with extraordinarily precise atomic clocks, sensitive enough to detect the tiny difference between a clock sitting on a table and one raised only about a foot higher. Somewhere right now, a clock on a tall mountain is ticking a hair faster than a clock resting quietly in a valley, and both of them are correct, each in their own gentle place. Some physicists describe the whole of time this way, using an idea sometimes called the block universe, or eternalism. In this view, the past, present, and future are not really separate. They all exist together, all at once, the way every page of a book exists together on the shelf, even though a reader only experiences one page at a time as they turn through it. Under this picture, no moment of your life is ever truly lost once it passes. It doesn't vanish behind you. It simply remains quietly on its own page, fully real forever, exactly as it was. There's one more piece worth resting on, about why the speed of light holds such a strange, protective place in all of this. Nothing with mass can ever reach or exceed it, and this isn't simply a matter of not yet having a strong enough engine. It's a deeper structural limit built into the shape of space-time itself. In a very real sense, the speed limit exists to protect cause and effect. If something could travel faster than light, it could, under certain conditions, arrive at an effect before its own cause, unraveling the same kind of contradiction the grandfather paradox threatens. The universe, it seems, quietly enforces this one gentle rule. Nothing outruns its own consequences, so that the whole fragile structure of before and after can hold together at all. In September of 2015, scientists using an instrument called LIGO detected something Einstein had predicted a century earlier, but doubted anyone would ever actually measure. A ripple in space-time itself, called a gravitational wave, produced by two black holes colliding over 1 billion years ago, far across the universe. By the time that ripple reached Earth, it stretched and squeezed the fabric of space by an almost impossibly small amount, thousands of times smaller than the width of a single proton. And yet the instruments, built with extraordinary care, felt it anyway. Time and space themselves had physically rippled ever so gently, and human beings, tiny and earthbound, managed to notice. That signal had been traveling for well over 1 billion years, since long before there were eyes on Earth capable of noticing anything at all, quietly crossing the space between galaxies, carrying the record of a collision from a time before our own sun had even formed. It arrived at exactly the moment humanity had finally built something delicate enough to feel it. A strange, patient kind of cosmic timing. A message written over 1 billion years ago, delivered right on time. There's something soothing in that, oddly enough. Time was never one single, rigid river flowing the same way for everyone. It bends gently around speed and gravity, stretching and compressing like something almost alive. And tonight, lying still, moving as slowly as you can, you are in the smallest, gentlest possible way, letting your own thread of time stretch out just a little longer than it would if you were rushing. The part that puzzled physicists for years was this: if motion is only ever relative, couldn't the traveling twin just as fairly say it was Earth that flew away from them, meaning it should be the earthbound twin who ages less instead? The gentle resolution lies in noticing that the two twins' experiences are not actually symmetrical. Only the traveling twin needs to fire engines to leave, slow down, turn around, and fire engines again to return moments of acceleration that the earthbound twin never experiences at all. That brief asymmetry, that one twin genuinely changing speed and direction while the other simply waits, is what breaks the tie and settles, without any contradiction, who truly aged less. It isn't an unresolved puzzle at all anymore, only a place where common sense simply needed a gentle update. There is something else worth resting on for a moment, this one about something much smaller and much closer than stars or speeding twins. A heap of sand. Imagine a heap made of 10,000 grains of sand. Now imagine removing a single grain. It's still obviously a heap. Remove another. Still a heap. If removing one single grain never turns a heap into a non-heap, then no matter how many grains you remove, one at a time, forever, it should logically always remain a heap, right down to a single, lonely grain sitting alone on the table. But that's clearly false. At some point, it stopped being a heap. The trouble is, no one can agree on exactly which grain was the one that mattered. This is called the Sorites paradox, or the paradox of the heap, and it's less about sand and more about the strange fuzziness hiding inside ordinary language. The same puzzle applies to a bald man losing hairs one at a time, or to the exact moment a color shifts from blue to green, or the precise second a child becomes an adult. Reality itself doesn't seem to mind these fuzzy edges. It's only our language, with its need for sharp categories, heap or not heap, tired or not tired, done or not done, that struggles to draw a clean line through what is actually a smooth, gradual slope. There's something quietly freeing in that, if you let it in. So much of daily worry comes from insisting on sharp, either or categories, succeeded or failed, ready or not ready, healed or still hurting, when most of real life is closer to that heap of sand, a long, soft gradient with no single grain that decides everything. You don't need to know exactly which grain you're on tonight. You're simply somewhere along the slope, gently, and that's enough. The same fuzziness hides quietly in a rainbow if you look closely enough. Somewhere in that gentle arc, red becomes orange, and orange becomes yellow. And yet, there is no single wavelength of light where anyone could draw a sharp, honest line and say, here, exactly here, is where one color ends and the next begins. The colors blend into one another so smoothly that human language, needing separate names for things, simply drew soft boundaries across a continuous slope of light and called the sections by different names. The rainbow was never really made of 7 bands. It was always one long, unbroken gradient, and the 7 names are just a kindness we offered our own minds, so they'd have something to hold on to. This same gentle blur appears in living things too, somewhere between one species and the next, across countless slow generations. A population of ancient creatures gradually became something different enough to deserve a different name. Yet no single generation, no single parent and child ever crossed a hard, visible line. Every offspring was always nearly identical to its parents. It was only the accumulation of thousands of nearly invisible steps that eventually produced something unmistakably new. The way a single grain never announces the birth of a heap, but 10,000 of them quietly, undeniably do. There's a related old riddle sometimes called the Ship of State, or in its oldest form, the Paradox of the Many, which asks a quieter version of the same question about groups of people rather than grains of sand. A committee loses one member and gains another. Is it the same committee? A team slowly replaces every player over several seasons. Is it the same team? A family gently grows, loses members to time, welcomes new ones by birth or marriage. Is it the same family? In every case, the honest answer seems to be both yes and no at once, depending only on which thread you choose to follow, the roster, or the ongoing story the roster serves. You are, in your own quiet way, both the heap and the story of the heap. The version of you that existed a decade ago has had nearly every one of its grains replaced by now new thoughts, new memories, new cells, new ways of speaking and seeing. And yet, nobody would say you stopped existing somewhere along the way. You simply crossed the same soft, ungraspable boundary that heaps and rivers and old ships cross constantly, without ever needing anyone to mark the exact moment it happened. There's a very concrete, very real version of this same fuzziness called the coastline paradox, first explored carefully by the mathematician Benoit Mandelbrot in the 1960s. It asks a question that sounds like it should have an easy answer. How long is the coastline of a country? But the length you measure depends entirely on the length of the ruler you use. Measure Britain's coastline with a 100-mile ruler, and you get one number. Measure it with a 1-mile ruler, tracing every bay and inlet, and the total grows longer. Switch to a 1-foot ruler, tracing every rock and pebble along the shore, and it grows longer still, seemingly without any limit, as smaller and smaller rulers reveal smaller and smaller wrinkles in the land. In principle, a coastline's exact length depends on how closely you're willing to look, and there is no single true number waiting underneath, only better and better approximations that keep growing the closer you zoom in. Maps, borders, and measurements are always, in some sense, gentle simplifications of something far more jagged and detailed than any ruler could ever fully capture, not unlike a life story, which also depends entirely on how closely you choose to look at it, and which never quite has one single, final, exact length either. There's a cousin of the heap paradox that lives inside language itself, rather than piles of sand, called the liar's paradox. Imagine a single sentence that says only this: this sentence is false. If it's true, then it must be false, exactly as it claims. But if it's false, then it must actually be true. It flips back and forth forever, refusing to settle on either side, a tiny two-word loop with no stable resting place. Logicians have spent well over 2,000 years gently poking at this same small sentence, tracing it back to the ancient Cretan philosopher Epimenides, and later sharpened by others. And it still resists a fully tidy resolution even today. Modern logic has learned to treat sentences like this less as broken problems needing repair, and more as evidence that language can construct shapes that simply fall outside the categories of true and false altogether. Not wrong, exactly, just built from a kind of self-referential knot that those two categories were never quite meant to hold. Some things, it turns out, were never meant to resolve neatly. They were only ever meant to be noticed, turned over gently once or twice, and then set down, unfinished, the way you might set down a small, strange stone you found on a walk, without needing to know exactly what it is before you keep walking. The same soft fuzziness settles over you every single evening, in fact, in the quiet hour between day and night. Astronomers actually divide twilight into 3 gentle stages. Civil twilight, when there's still enough light to move around easily outdoors without help. Nautical twilight, when the horizon grows too dim to clearly separate sky from sea. And astronomical twilight, when the sky finally grows dark enough for the faintest stars to appear. And yet, even these 3 careful categories are just slightly more precise heaps stacked on top of the same underlying problem. The sun sinks below the horizon by smooth, continuous degrees, and night never actually begins at any single, sharp instant. It simply, gradually, gently arrives, the way the heap gradually stopped being a heap, the way rest gradually arrives too, somewhere in the soft, undefined space between being awake and being asleep, with no single grain of a moment you'll ever be able to point to and say, there, exactly there, is where I crossed over. There's an older, more personal version of this same puzzle, sometimes told as the paradox of the bald man, which sits right beside the heap as one of the oldest vagueness puzzles on record. Losing a single hair never makes a full head of hair suddenly bald. But losing hairs one at a time, if it never once counts as the deciding moment, should mean baldness never truly arrives at all. And yet it plainly, visibly does, for some people, at some point. The same soft slope applies to hair turning gray, one strand at a time, or skin gradually gaining the marks and lines of a long life. There was never a single morning when any of it happened. It only ever arrived the way all heaps do, by accumulation, so slow and so continuous that no single day could ever fairly be blamed or credited for the whole change. Every gradual mark time leaves on you was earned exactly that gently, one unremarkable day folded quietly onto the last, and none of them were ever a single, sudden loss. There is one more paradox left tonight, and it belongs to the night itself, to the simple, ordinary darkness above you. Here is the question: if the universe is infinite, or even just extremely large, and filled with countless stars scattered in every direction, then no matter which direction you looked, your line of sight should eventually hit a star. Every single point in the sky should be glowing with starlight, layered infinitely deep. The whole night sky should be blazing white, all the time, everywhere. And yet, it obviously isn't. It's dark. This is called Olbers' Paradox, named after the German astronomer Heinrich Olbers, though versions of the question had been quietly puzzling thinkers for centuries before him, including, in a strange twist, the writer Edgar Allan Poe, who in a long prose poem called Eureka in 1848 proposed an answer remarkably close to the one scientists would later confirm. The gentle resolution came much later, once astronomers understood that the universe has a finite age, roughly 13.8 billion years old, and that light travels at a fixed, finite speed. That means we can only ever see stars whose light has had time to reach us since the universe began. Beyond that boundary, called the observable universe, there simply hasn't been enough time yet for any light to arrive at all. The darkness between the stars isn't proof of emptiness. It's proof of unfinished time, starlight still quietly making its way toward you, some of it for billions of years, most of it never arriving in your lifetime or in anyone's. There is a second, quieter layer to this same darkness. The universe isn't just finite in age. It is also expanding, stretching a little more every moment, carrying galaxies farther away from each other as it goes. As light from very distant, very old sources travels toward us across that stretching space, it gets stretched too, shifted toward longer, redder wavelengths, sometimes so far that it slips entirely out of the range human eyes can see. Some of the oldest light in the universe isn't invisible because it never arrived. It arrived and stretched until it became a kind of very faint warmth instead of visible light at all. That faint warmth actually has a name: the cosmic microwave background. And it is, in effect, the oldest light there is, released roughly 380,000 years after the beginning of everything, when the universe first cooled enough to become transparent. It fills the entire sky in every direction, arriving constantly, gently, all the time, far too stretched and faint for human eyes to see without special instruments. In a very real sense, the true dark night sky isn't dark at all. It's glowing softly, everywhere, all at once, with the oldest surviving light in existence, a kind of ancient, quiet nightlight left on since almost the very beginning, that has simply always been just past the edge of what your own eyes can perceive. There's a gentler, more everyday version of this same darkness worth noticing. 2. The quiet difference between a blue daytime sky and the black sky astronauts describe seeing from orbit, even in full daylight. During the day, sunlight scatters off the countless tiny molecules of Earth's atmosphere, and blue light happens to scatter far more easily than red or yellow light, filling the whole sky with that familiar soft blue glow, bright enough to completely hide the stars behind it. Once you rise above the atmosphere, there's nothing left to scatter the light that way, and the sky simply returns to its true, quiet color, black, with the sun a sharp, brilliant point rather than a soft, glowing disk, and stars visible even in what would, on Earth, be broad daylight. The blue sky you're used to was never really about the sun or the stars at all. It was always a delicate, local trick of scattering light. A thin blue blanket draped only across the part of the universe close enough to our own gentle atmosphere to be touched by it. There's one more gentle piece of the darkness worth resting on, about where exactly all of this is happening. It's tempting to imagine the universe as a great sphere expanding outward from some central point, with Earth sitting near the middle, or near an edge, somewhere findable on a map. But astronomers describe it differently. The universe, as far as anyone can tell, has no center and no edge at all. Every single galaxy sees every other galaxy moving away from it, in every direction equally, which means there is no special vantage point, no true middle, no there to be near or far from. Wherever you happen to be standing, the universe looks, in its broad average shape, exactly the same as it would from anywhere else. It isn't expanding into some larger empty space, the way a balloon expands into the room around it. Either space itself is what's stretching, everywhere, all at once, without needing anywhere to expand into. It's a difficult picture to fully hold in an ordinary mind, and you don't need to hold it perfectly tonight. It's simply worth knowing, gently, that wherever you are lying right now, you are not on the edge of anything, not off to one side of some grand center. You are, in the only way that has ever mattered to the universe, right in the middle of it, exactly like everyone else, everywhere. There's one more quiet twist folded into this darkness. Everything you can actually see in the night sky, every star, every planet, every glowing cloud of gas, makes up only a small fraction of everything that exists. The rest, roughly 95% of the universe by mass and energy, is made of something scientists call dark matter and dark energy, neither of which gives off or reflects any light at all. We know they're there mostly by their gentle gravitational fingerprints, the way galaxies hold together more firmly than their visible matter alone could explain, the way the universe's expansion keeps quietly accelerating rather than slowing down. In a very real sense, almost all of the universe is dark, not because it's empty, but because it's simply built from something light has never learned how to touch. And yet, scientists who once averaged the color of all the light in the universe across hundreds of thousands of galaxies found that its overall hue is a soft, warm, slightly beige-white shade they half-jokingly named cosmic latte. The universe, taken as a whole, blended together, all its fierce blue stars and dim red ones, all its glowing gas and quiet dust, comes out looking something like the color of a gentle, milky cup of coffee. Somewhere above you tonight, the whole vast, dark, mostly invisible universe is, in its own strange average way, wearing a color almost exactly like warmth. If you let your mind wander far enough into the future, trillions of years from now, long after tonight, long after every star you could ever name has quietly burned through its fuel, scientists describe an era, sometimes called the heat death of the universe, a time when even the last dim embers of starlight have faded, and matter itself has drifted so far apart that almost nothing happens anywhere, ever again, except a slow, patient, nearly eventless stillness. It sounds, at first, like something to fear, but it is unimaginably far away, trillions upon trillions of years distant, a span so vast that the entire history of Earth so far would barely register as a single heartbeat against it. There is no need to carry that horizon tonight. It is simply there, softly, at the very end of the story, the way the last page of a very long book waits patiently on a shelf, unread, unneeded, until long after every other page has already been gently turned. Above you tonight, the universe is steady and calm. It has been unfolding for nearly 14 billion years, and it will keep gently unfolding long after tonight, long after this recording ends, long after any of the small worries of today. So the sky above you isn't empty. It's simply patient, full of light still arriving, one soft photon at a time, from places so far away that far barely means anything anymore. You don't need to hold on to any of this now. Not the ships, or the grandfather, or the tortoise, or the twins, or the heap, or the darkness overhead. You can let it all soften into impression. A few warm shapes drifting somewhere behind your closed eyes. Nothing you need to hold tightly. Nothing you need to remember by morning. None of these 7 paradoxes were ever really about ships, or clocks, or sand, or stars. They were about the soft, forgiving space where certainty is allowed to loosen, where a thing can be old and new at once, here and gone at once, true and untrue at once, without the whole world falling apart because of it. You are allowed that same softness tonight. You don't have to be fully resolved, fully finished, fully certain of anything in order to rest. You are allowed to be a little bit unfinished, the way every good paradox is, and still be completely, quietly whole. Let your breathing slow again, the way it did earlier. Let it get even quieter now. Let your body sink a little further into wherever it's resting. Let the day, whatever it held, begin to loosen its grip on you, one small piece at a time, the way a hand slowly opens. There's no need to hold on to today any longer. Let it go soft. Let it go quiet. Above you, whether you can see it tonight or not, the universe is still steady, still turning gently, still unhurried by anything happening down here. It was patient long before you existed. It will stay patient long after you've fallen asleep. And it asks nothing of you in return, only that you rest. If you'd like to, your body already knows how to rest. Sleep well and good night.